Total internal reflection through a 45 degree, 90 degree, 45 degree prism. This prism is also called a right angled isosceles prism. A prism having an angle of 90 degree between its two refracting surfaces and the other two angles each equal to 45 degree is called a total reflecting prism, because the light incident normally on any of its faces suffers total internal reflection inside the prism. Here our purpose is to deviate a ray of light through 90 degrees. ABC, as you can see in the figure, is a total reflecting prism. A beam of light is incident normally at the face AB. It passes undeviated into the prism and strikes the face AC at an angle of incidence equal to 45 degrees. For glass air interface, the critical angle is about 42 degrees. Therefore, the beam of light suffers total internal reflection at the face AC. The angle of incidence is greater than the critical angle. The reflected beam inside the prism then strikes the face BC, where it is incident normally and therefore passes undeviated. As a result, the incident beam gets deviated through 90 degrees while emerging out of the prism. Path of two rays, PQ and P', is shown here. So, using this right angled isosceles prism, we can deviate the ray of light through 90 degrees. In this case, our purpose is to deviate a ray of light through 180 degrees using the right angled isosceles prism. PQ is the object. A ray of light from point P falls normally on AC. So now it will enter the prism in an undeviated manner and it will strike the glass air interface AB. The beam of light is traveling from the glass to air at an angle of incidence equal to 45 degrees, which is greater than the critical angle 42 degrees for glass air, and therefore the beam of light suffers total internal reflection. The reflected beam inside the prism strikes the face BC at an angle of incidence equal to 45 degrees. So it again suffers total internal reflection. The beam of light inside the prism now falls normally on the face AC and therefore passes out undeviated. And you will get point P'. Similarly, incident ray from point Q onto the face AC will enter the prism in an undeviated manner. It will strike AB, the glass air interface. The angle is 45 degrees with respect to the normal, which is greater than the critical angle, which is 42 degrees for glass air, and therefore this ray will also suffer total internal reflection. It will strike the face BC, where again it will suffer total internal reflection, and then it will emerge out of the prism and point Q' is obtained. So P', Q' is the image. So the ray of light has been deviated through 180 degrees using this right angled isosceles prism.